Okay, go ahead and pause and do the homework check. Today's lesson is Chapter 1, Lesson 7, Functions. So yesterday we talked about relations, and today we're going to be talking about what's the difference between a relation and a function. So a relation is just a set of values, and in a function, the difference is it's a set of values also, but our x values for a function cannot repeat. Then for a reminder, which variable is the domain? It's the x's, and which variable is the range? Is the y's. Something new here we have is the vertical line test. And the vertical line test is any vertical line drawn on the graph may only touch the line in one place. So usually what you're going to do is take your pencil and you're going to slide it across your line and make sure that as you're sliding at each point, your graph is only touching your pencil in one place. All right, so the first thing is we have a bunch of data here, and we're going to determine whether this is a relation or a function. So remember, the difference is in a function, the x values cannot repeat. So I'm checking this mapping first. My values or my coordinates are -3, 0, -2, 3, 1, -2, and 5, 3. So the only thing to determine whether or not this is a relation or a function is check the x values. So I have -3, -2, 1, and 5. None of them are repeating, so this is a function. Next, I'll check my table, check the x values only. So I have 1, -4, 7, 1. Notice here the 1 repeats, and so this one is a relation. Okay, on this one, I can do the vertical line test. So I'm going to go ahead and connect those dots, use a blue pen as my pencil. So as I'm dragging my pencil across the screen, notice at any point, it's only touching the graph in one spot. So here it touches once, touches once, touches once. And so if it passes the vertical line test, then this one is a function. So an example of one that would not be a function is if it looks something like this. So at this point here, if I would draw a vertical line, it's actually touching my graph here, here, and here. So this one would be a relation. Okay, next I have a set of points here. Let's check. -1, 2, 3, -6, -3. No repeat, so this is a function. This one, 6, 2, -4, 4, 2. The 2 repeats, so this one is a relation. All right, the next thing we have here is just x equals a number. So we have to take some notes about vertical and horizontal lines. So for a vertical line, the equation is always x equals a number. There's no y. So it will not cross the y-axis. Then for a horizontal line, it's always y equals a number, and there's no x, so this one will not cross the x-axis. So if I'm going to draw a picture of x equals -2, I go on the x at -2 and I put a vertical line. And these vertical lines are always relations. Because if I pick 2 points and I list them, it'd be like -2, 1 and -2, 2. My x's are repeating. So that one is always a relation. Now for the horizontals, if I draw it, y at +2, this one would pass my vertical line test. So these ones are always functions. Okay, the next thing we have to talk about is what is function notation. So in pre-algebra, they always used y equals for relations and for functions. In Algebra 1, if they know it's a function, aka it passes the vertical line test or it has no repeating x terms, they're going to use f of x equals. But just remember that y equals and f of x equals are the same thing. They can just use y equals also for relations, but it can be used for both. Suppose you want to find the value in the range that corresponds to the element 2 in the domain. So how they would write that is they're telling you that that is a function and they're writing it this way. And you read that as the function at 2. So f of 2. And so if they're asking you to find the function at 2, we're going to use substitution in the x spot. So this one says, let f of x be 2x minus 6 and g of x, which is just a second function, be x minus 2x squared, find each value. So the first one says, go to the f function and put 2 in for x. So instead of writing down 2x minus 6, I'm going to do 2. And in the x place, I'm going to substitute in this 2 minus 6, and that would give me -2 as an answer. On this next one, they're telling me to substitute in -1/2. So I start with my f function, which is 2. And instead of x, I'm going to substitute in -1/2 and then -6, which gives me -7. On this one down here, they're asking me to substitute in -1/3 into my g. Go away, down, there. Into my g. So instead of starting with an x, I'm going to start with -1/3 minus 2, open. I'm going to put in -1/3 again, squared. And when I type that in, I'm going to type it exactly how it's written. So I'm going to do open parenthesis, -1 divided by 3, close, minus 2, open, -1 divided by 3, close, squared. And then I got a decimal, so I'm going to math enter, enter, and I got that to equal -5/9. On number 12, they're asking me to do two things. They're asking me to put the 7 in the function, but then also behind it subtract 9. So I'm going to start with the f function. So I'm going to do 2, sub in the 7, minus 6. And then behind that, I'm also going to subtract another 9. And I get -1. Same thing on this one. I'm going to do the g function this time. I'm going to substitute in -3. So -3 minus 2, parenthesis, -3 squared. And then behind that, I'm going to add plus 13. And I get -8. These ones down here, we're not going to worry about those. That's more of an Algebra 2 concept that we will do later on in the chapter. So for this lesson, we're just going to ignore them. Okay, Martin earns $7.50 per hour proofreading ads at a local newspaper. His weekly wage, W, can be described by the equation W equals 0.75H, where H is the number of hours worked. Write this equation in function notation. So in function notation, instead of W equals, we're going to use f of x equals. And then instead of the h, we're going to put the x there. On part B, find f of 15, f of 20, and f of 25. I'm just going to make like a little quick table here. I know I'm putting in 15, 20, and 25 in for my x's. So for this first one, f of x. I'm going to put in 7.5 times 15 in my calculator, and I get 112.5. 20 times 7.5 is 150. And 25 times 7.5 is 187.5. The table shows the relationship between the resistance R and the current I in a circuit. Is this relationship a function? Explain. So we go ahead and check the x values. 120, 80, 48, 6, and 4. No repeats. No x repeats. So it is a function. If the relationship is represented by the equation I times R equals 12, rewrite the equation in function notation so that the resistance R is a function of the current I. So we want to be able to have I instead of f of x. Well, the first thing we're going to do is get I by itself. I'm going to need to divide each side by 12, or by R, the 12 by R. So that gives me I equals 12 divided by R. And it wants that in function notation. So I'm going to do f of x equals 12 divided by x. It wants to know what is the resistance in a current when the current is 0.5 ampere. So we put 5 in for my I, because it says I up here is the current. So I'm going to put 0.5 in there. And so then in order to get x by itself, I'm going to need to do cross products. So 12 times 1 is 12. 0.5 times x is 0.5 x. Divide each side by 0.5. And x equals 24. And there's your concept check.